Welcome to part 4 of the Tidyverse. Up until now, I have been demonstrating some of the capabilities of the Tidyverse package, showing you how we can use it to clean data or present cool graphs. But now we're going to start digging in and learning step by step some of the elements. What I'm going to be doing first is still giving you a little bit of an overview of the graphical features of the Tidyverse, but enough of an overview so that you can start playing around in the sandbox and testing things out for yourself. And then in our next video series, we're going to take it very systematically so that you can become even more adept and have more expertise at creating graphics in R using the Tidyverse package. After we're done with graphics, we'll work our way onto the many other elements of the Tidyverse. But first, let me give you a little bit of an overview of what this is. Tidyverse is actually a package that contains a bunch of packages. ggplot2 is a graphical package. dplyr is a data manipulation package. Tidyr is a package for getting data tidy, and as we're going to learn, that doesn't just mean that it's neat. It has a very formal definition. readr is a package for reading data. purrr or purr is a package of tools for working with functions and vectors. Tibble is the core object used in the Tidyverse, and it replaces the data frame. Actually, it's a special type of data frame. Stringr is a package of functions for working with strings, that is, character vectors. And forcats is a package of functions for working with factors. All of these put together are called the Tidyverse, and then there's even more. There are other packages that are in the Tidyverse, but they're used less frequently. So they're not loaded automatically when the Tidyverse is loaded. When you install the package called Tidyverse, you're installing all of these packages that I have listed here. If someone were to start out installing just one of these packages, they can do so. They don't have to install the whole Tidyverse. But since we're going to be working with all of it, I want you to go ahead and install the whole Tidyverse. But what I'm telling you here in this last bullet is that there are some other packages that are in the Tidyverse that are not automatically installed, nor are they loaded when you use the library command with Tidyverse. So before we leave this topic after several weeks, we probably should take a look at what those packages are so we know about their existence and can install them and load them if we need them. But for now, we're going to stick with the core Tidyverse packages. So if you've not already done it, and I think you probably have because you probably followed along in my demo, you need to install Tidyverse on your system. Obviously, anytime we want to run it, we're going to use library Tidyverse at the top of our notebook. I can tell you that anyone who becomes accustomed with the Tidyverse, like I have, they pretty much use it in every notebook that they write. So my notebooks, by default, start off with the library Tidyverse call right at the beginning so that these functions are all available to me. And here's the main man. Here's the inventor of the Tidyverse. His name is Hadley Wickham. He happens to also be the chief scientist at RStudio. That's actually just one of his jobs. This guy does so much, I don't think he ever sleeps. He is on the faculty at 3 universities. I believe one of them is maybe Auckland in New Zealand. Another one I think might be, is it Rice? I think so. And then I know the third one is Stanford University. So in addition to his job at RStudio, he lectures in all these 3 universities. He's also asked to give keynote addresses very frequently at statistical and data science conventions. He's the author of many R packages. He's the author of many books on R and data science. And the cool thing about his books, and you're going to see me link to some of them on Blackboard, is that for all his books, he has both a printed edition for those who want it at some cost, and it's usually not a very high cost, and then he has an electronic edition that's always free. So you can actually read all of his books on R and data science without paying a cent if you want to. He refers to himself as nerd famous. I added the rock star. This is a man who is so well known in the world of R and statistics and so admired for really taking R and turning it into something substantially more powerful than anyone ever imagined. He's so well known for that when he goes to conventions, he needs to have time booked where he can be at a booth and people can come stand in line to take selfies with him. So he refers to himself as nerd famous, and I added the rock star part. I've got his website there if you're interested. It's hadley.nz because he is from New Zealand. You may recall that the original inventors of R were from New Zealand as well, the two Roberts. Okay, so that's Hadley. And let me give you a little flavor for his thought processes with a few quotes. He said, fundamentally learning about the world through data is really, really cool. And he tried to make it really cool with his Tidyverse package. This one shows a little bit of his humor. Good coding style is like correct punctuation. You can manage without it, but it sure makes things easier to read. And I have tried to stress that point. I refer to it as good hygiene. And this includes things like using appropriate variable names and function names when we write our code, so that when we get more and more code under our belt and in our library that we create, that it will make sense to us. And along with that, he says this, and I can tell you from experience, this is so true. In every project, you have at least one other collaborator. You might think, what? No, I do most of my work alone. But that other collaborator he's referring to is future you. And you don't want future you to curse past you. That is, sometime in the future, it might be 3 months, 6 months, or 6 years from now, you're going to need to look at your R notebooks, and you're going to need to draw from them, and you're going to need to reproduce some things you've done. And so one of the reasons that we're now using GitKraken and GitHub is so that we can help reproduce what we've done. Even if we don't show it to anyone else, at some point, I guarantee you, you're going to need it again. And that's your collaborator, future you. So you don't want future you in 6 years from now to be present you and come and curse out past you from 6 years ago. And then this final quote, one of my favorites of his, and I agree with him, you can't do data science in a GUI. GUI, of course, stands for Graphical User Interface, which we're so used to using in programs as a way of helping make it easier to run the programs. So if I take a package of statistical analysis that uses a graphical user interface, so that I have pull-down menus that make these functions available to me just by pointing and clicking, I cannot do the same things with those that I can in a package in which I'm actually coding. That graphical user interface that makes it friendly for the user hides something nasty, and that is you have an inability to take things like messy data and missing data and data that is just not conforming to your specifications. And furthermore, you can't get it to do everything that you want it to do. Researchers should be thoughtful about the research process and be every step of the way having the software be a tool. I see too many people who make the software the decision maker rather than it being a tool to do what you want it to do. So you can't do data science in a GUI. A very important model of data science is Hadley-Wickham's, and we're going to build a lot of our learning from here to the end of the semester around this model. This is how he sees data science working. And all of this he puts into this rectangle that he refers to as our program. We import the data. So somewhere we have it out there. We've collected it in an Excel spreadsheet, or it sits there in a pile of paper surveys, and we have to somehow get it into R. So there are tools in the Tidyverse that go beyond what we've been using for getting data into R. Then once we have it into R, we have to tidy it. And as I've already mentioned, we're going to learn that tidy data doesn't just mean not messy or neat. It has a very formal definition. When it's tidied, we may or may not have to transform some of the data. We're going to look at examples later on in which we have to transform the data so that we can work with it. And then once the data is transformed, notice this, and this kind of goes along with, if you took statistics from me, how I teach statistics, we start with graphical displays. We start with visually analyzing our data. That visual analysis might lead us not just to answers to our research questions, but new questions, and perhaps answers we did not anticipate. This is where we're going to start our exploration of the Tidyverse, is with the visualizing. So I'm going to give you data that's already been cleaned, tidied, transformed, so you can visualize. And then later on, I'll give you more messy data and teach you how to put it in a format so that we can visualize. Once we visualize, then we create our models. We think we see general principles in our visualization, so we put that into a model form. That model could be descriptive or inferential in nature. Once we've done that, it comes full circle, because at that point, we may have discovered that we need to do more transformation of our data to find out new things. And so we visualize again. I can tell you that that circle loops around with a large grant project like the one I'm in 2 or 3 times as I visualize initially what we wanted to look at, but then we start saying, but what if, but what if, but what if? And we end up transforming and creating new variables that we didn't have when we started, and then visualizing with them and modeling with them. And finally, we communicate. And I have had you start to use R notebooks because R notebooks are very valuable. The fact that you can bring in R Markdown and combine code with your output and put those into a nice readable format, that's part of the communication stage. Hadley-Wickham's books that he writes, and he will tell you this on his web pages, they're all written using R, and he publishes the electronic books using a package in which you can publish in R. So this is his model of data science. If you'll join me in the next video, we're going to start learning how to visualize with the Tidyverse. I'll see you there.